So hey guys, hello and welcome back to the channel. This is me Pritham Paikre and you are watching Step 2 Math. So today in this class we will be discussing about the zeros and the coefficient of the polynomial. In the last class I have told you what are polynomials, what are the degree of the polynomials and what are the zeros of the polynomial. Today we will just go one step ahead and we will see what is the relationship between a zero of a polynomial and coefficient of the polynomials. So let us consider a general equation of the polynomial, or I am considering the general polynomial. You know that. So px is equals to a naught plus a1 x plus a2 x squared and so on up to an x to the power n. So this is the general form of a polynomial of degree n if an is not equals to 0. Actually, I have told all these things in the previous class. So now, what is the zero of the polynomial? So I will be saying k is a zero of a polynomial. So k is zero of a polynomial if p of k is equals to 0. Okay, if the value of the polynomial p of x at k is equals to 0, then I will say the polynomial to be the k to be the zero of the polynomial p of x. So if I will consider a polynomial, say linear polynomial p of x is equals to 2x plus 3. So if I will consider a polynomial p of x is equals to 2x plus 3, so what will be the zero of this polynomial? So again I will say, suppose k is the zero of this polynomial, then my p of k must be equals to 0. That implies if I will substitute k in place of x, so you can see it will be 2k plus 3. And if this will be equals to 0, this implies k will be equals to minus 3 by 2. So I can say p of minus 3 by 2 is equals to 0. Hence, minus 3 by 2 is the zero of this polynomial. Px is equals to 2x plus 3. Okay, so here you can notice something, that is, this will be equals to minus, this is the constant term. So this is the constant term divided by coefficient of x. Okay, so I will be so fine. So actually, what is the relationship between a 0 and the coefficient of the polynomial? So I will be saying, okay, so 0 is nothing but that is equals to minus the constant term divided by the coefficient of x. It is for the linear polynomial. So is this property hold for any polynomial p of x of degree 1? So let us consider the general form. So I will be saying, if I will consider a polynomial p of x is equals to ax plus b. So I will be saying x is a zero of the polynomial if ax plus b is equals to 0. That implies x will be equals to minus b by a, that is equals to minus the constant term divided by coefficient of x. Okay, so divided by coefficient of x. So this is my relationship between the 0 and the coefficient of the linear polynomial. So let us consider a quadratic polynomial and let us see what is the relationship between the 0 and the coefficient of the quadratic polynomial. So let us consider that. So first of all, let us take a particular example. I will be saying p of x is equals to 2x squared plus 8x plus say 3. Okay, so it is let me say it is 6. Okay, so let us consider the polynomial p of x is equals to 2x squared plus 8x plus 6. So first of all, how to find the zero of this polynomial? So in the last class, I have told you how to find the zero of a polynomial or a zero of the quadratic polynomial. And also in class 9, you have came across a method that is called the middle term factorization. Okay, so by doing the middle term factorization, you have solved the quadratic equations. So here these are the quadratic equation, or these are my quadratic polynomials. So how to solve that? As you know, the method, the middle term factorization method that says I have to split this middle term into two parts such that the product of these two parts will be equals to 2x square into 6. Okay, so how to make factorize this how to make the middle term factorization? So you can see it will be equals to 2x square plus 6x plus 2x plus 6. Okay, so this will be equals to 2x square plus 6x plus 2x plus 6. So as you can see, 6x plus 2x is equals to 8x. Okay, so the sum of these two terms will be equals to the 8x and the 6x into 2x, so it will be equals to 12x square. So as you can see, this is equals to 2x square into 6. Okay, so this is actually the technique for the middle term factorization. So by using this technique, actually you can solve any quadratic equation and you can find the zeros of this quadratic equation. Okay, so let me just solve this first. So this will be equals to, so it will be x plus 3 plus 2. So it will be x plus 3. So that will be equals to 2x plus 1 to x plus 3. Okay, so I can just factorize this quadratic polynomial p of x is equals to 2x square plus 8x plus 6. So that will be equals to my 2 whole into x plus 1 into x plus 3. Okay, then what is the zero of this polynomial? So I will be saying the zero of the polynomial at that term such that when I substitute that in place of x, I will be getting the result as my 0. So here you can see p of x is equals to 2 whole into x plus 1, x plus 3 is equals to 0 implies x plus 1 is equals to 0 or x plus 3 is equals to 0 because 2 can never be 0. So this implies x is equals to minus 1 or x is equals to minus 3. So these are my 0 of this quadratic polynomial. So now what you observe here is that minus 1 minus 3 is equals to, that means sum of these 0 will be equals to minus this is minus 8, or I can say this is equals to minus 4, again that is equals to minus of 8 by 2. Okay, so this is minus of 8 by 2. That is nothing but that is equals to minus of coefficient of x divided by coefficient of x square. Okay, so this is coefficient of x divided by coefficient of x square. Similarly, if I consider the product minus 1 into minus 3, so that will be equals to 3, which is equals to 6 by 2. So that is equals to coefficient or that is the constant term divided by, that is the constant term divided by coefficient of x square. Okay, so here you get two things, that is the sum of two zeros is equals to minus coefficient of x by coefficient of x square, and the product of these two zeros will be equals to the constant term divided by coefficient of x square. Okay, so now the question arises here is that is this thing possible for any quadratic polynomial or for any quadratic equation? So let us consider that. Okay, so let me take the generalized form of a quadratic polynomial p of x is equals to ax square plus bx plus c, and let us find what will be the relationship between the 0 and the coefficient of the polynomials. Okay, let us consider the polynomial p of x is equals to ax square plus bx plus c. Let alpha and beta be zeros of the polynomial p of x. Okay, suppose this is the zeros of the polynomial p of x. That implies I can write p of x is equals to ax square plus bx plus c, and that is equals to a constant k whole into x minus alpha into x minus beta. Okay, and that will be equals to 0. Fine. Or I can say x minus alpha into x minus beta. Let it be like this. So clearly you can say, if I will be substituting alpha in place of x, so you will get the right hand side as your 0. And similarly, if you substitute x is equals to beta, then again you can also get the right hand side is equals to 0. Hence, alpha and beta are the 0 of this polynomial. Okay, so now let us expand this right hand side. So you will be seeing k whole into x square minus alpha x minus beta x plus alpha beta. Okay, now if I will just equate these two equations, one is ax square plus bx plus c, and one is kx square minus alpha kx minus beta kx plus alpha beta into k, then let us see what happens. So you can see my a will be equals to k, and my alpha minus beta will be equals to b, and okay, let me solve this first. So this is equals to kx square minus k alpha x minus k beta x plus k alpha beta. Okay, so if I just equate these two equations, so you can see the two equations will be equal if the coefficient of x square is equals to the coefficient of x square in the second equation, and likewise, so I will be saying k is equals to a. Similarly, minus k alpha minus k beta is equals to b, and k alpha beta is equals to c. Okay, so this implies k is equals to a. That implies alpha plus beta is equals to minus b by a, and alpha into beta is equals to c by a. Okay, so then what is the relationship between the zeros and the coefficient of the polynomial, that is the quadratic polynomial? So let us consider that. So I will say sum of two zeros is equals to minus b by a, that is equals to minus coefficient of x divided by coefficient of x square. Similarly, the product of two zeros is equals to minus c by a, that is equals to c by a, that is equals to the constant term divided by coefficient of x square. Okay, so these two are the relationship between the zeros and the coefficient of the polynomial. Now the question arises, what is the need of finding such type of relationship between the zero and the coefficient of the polynomial? So I will be just giving you one application to it. Suppose I will be given two zeros of a polynomial of two zeros, and I have to find a quadratic polynomial whose zeros are some alpha and beta. Then by using this relation, I can find the set of all polynomials or all quadratic polynomials whose zeros will be my alpha and beta. So let us take one example and let us see what happens in that example. So fine. So let me consider the polynomial, or I will be saying, okay, let us consider two examples rather. So the question is, if px is equals to 3x square plus 6x plus 3, then find the zeros of px and verify the relationship between zeros and coefficient of p of x. Okay, so it is very simple. I have just little bit earlier I have just given you the particular case for the relationship between the zero and the coefficient of a polynomial, but let us see this question. So here I am having p of x is equals to 3x square plus 6x plus 3. Okay, so now again I will just factorize this to find the zero of this polynomial. So again I will consider the middle term factorization technique. So what does that middle term factorization says? So I have to split this middle term into two parts such that the sum will be equals to 6x and the product will be equals to 3x square into 3. So let us see. So if I split this into two parts, so let us 3x square plus 3x plus 3x plus it will be 3. Okay, so as you can see, this middle term 3x plus 3x is equals to 6x and 3x into 3x is equals to 9x square, that is equals to 3x square into 3. Okay, 3x square into 3. Fine. So this is actually the rule for the middle term factorization. So I will not go through that deeply. So we'll just focus in this question. Okay, so this will be equals to 3x, so it will be x plus 1 plus 3 common, so it will be x plus 1. So this will be equals to x plus 1 into 3x plus 3, or I can say it is 3 whole into x plus 1 into x plus 1. So here my alpha is equals to 1 and beta is also equals to 1. Fine. So here my alpha is equals to 1 and beta is also equals to 1. So let us verify this term. Okay, so let me just erase this and we will just verify the terms. Okay, so 1 plus 1, 1 plus 1, okay, is equals to, what will be the this thing? So I will be saying this will be equals to 2. So this is my LHS. Okay, now my RHS, so it will be equals to minus b by a, that is equals to minus 6 by 3, so it is equals to minus 2. Okay, so it is equals to minus 2. This alpha is equals to minus 1 and beta is equals to minus 1, because here the two zeros will be equals to minus 1 and minus 1, because if I substitute minus 1 in terms of x, I will replace a minus 1 in place of x, so you will see it will be 0. So the zeros will be minus 1 and minus 1. That means the zeros are the W zeros. So we'll just discuss that type of zeros in the next chapter. So, but till then, we'll just consider, okay, the zeros are minus 1 and minus 1. So here LHS will be equals to 2 and LHS will be equals to minus 1 plus minus 1. So it will be equals to minus 2 and RHS is equals to minus 2. So this first condition is satisfied. So similarly, let us consider the second one. So that is minus 1 into minus 1. So that is equals to 1. And what is C by A? So my C by A is equals to 3 by 3. So it will be equals to 3 by 3, that is equals to 1. So here also the second condition is satisfied. Fine. So that implies I can say, yes, it is verified that if alpha and beta are the zeros of the quadratic polynomial, then alpha plus beta, the sum of the two zeros, will be equals to minus coefficient of x by coefficient of x square, and the product of these two zeros will be equals to coefficient, that will be the constant term divided by the coefficient of x square. So it is actually the important thing for you guys. Okay, so now actually we will consider the next question to see what will be the necessity of this relationship. So if I consider a question, let us see, let's say the question is something like this: find the polynomial of degree 2 whose sum and product of two zeros are 3 and 1 respectively. Okay, so fine. That means I am having alpha plus beta is equals to 3 and alpha into beta is equals to 1. So that is equals to minus b by a, and this is equals to c by a. So let b is equals to minus 3, a is equals to 1, c is equals to 1. Okay, so you can see if my b is equals to minus 3, my a is equals to 1 and c is equals to 1, so minus b by a, that means minus 3 by 1 is equals to 3, and 1 by 1, that is equals to 1. Okay, so fine. So this value of APC satisfies this relation. Okay, so now what will be my polynomial? P of x is equals to ax square plus bx plus c, so that is equals to I can say it is x square, or I can say just like this, so it will be equals to k into x minus alpha into x minus beta, and that I can write as my k whole into, okay, this will be my k whole into x square plus, or it is minus 3x plus 1. Okay, so that means any polynomial of this form, k is any constant. Okay, I don't have any problem if I consider any constant k except 0. So this will be giving me a polynomial of degree 2 and whose zeros satisfies the condition alpha plus beta is equals to 3 and alpha into beta is equals to 1. So you can check actually this type of polynomial satisfies these conditions. Okay, so similarly if you can see what will be the relationship between the zeros and the coefficient of the polynomial in case of a cubic polynomial. Okay, so this is a task for you. You can check and you can enjoy the relationship between these cubic polynomial, the zeros and the coefficient of this cubic polynomial. So in the next class we will be discussing about the next, we will go to the next chapter, and for today it is all about our polynomials. Just so thank you for watching this. Stay safe and stay healthy.